Hi there. This is in response to some negative comments that were received on the Flipping Physics physics channel. Really taken to heart and kind of really bothers me as a fellow physics educator that basically Mr. P was torn down by a certain somebody that thought that they actually knew better. I have no doubt that probably Mr. P is not the utmost expert in physics, as I would never claim myself to be the utmost expert in physics. However, I do feel that, being in this field long enough, you're going to make some mistakes. You're going to learn from those mistakes. And hopefully, if you're very reflective on those things in life, you're going to make different choices to try to avoid those same mistakes. And I think that's exactly what Mr. P was trying to do. So I applaud him for that. So I want to take you through some thought processes here. I want to provide a different viewpoint maybe on some things. I'm not trying to claim that I know more, but maybe that I just know things a little differently. And I will admit that this is not a polished video. I am doing this in one take, and I am not going to edit it. So there's probably going to be some mistakes along the way. I'll try to fix them as it happens, but there's a chance you're going to find one or two, and I'm okay with that. So let's get started. So let's talk about some preliminary items. I'm not going to spend a ton of time on this because I want to try to keep this as short as possible. So first of all, this idea of open, closed, and isolated systems used to be an idea that was taught in the AP Physics class. They've kind of taken these ideas out, but I think it's illustrative to at least think about them. So an open system is one in which that is open to outside influences. So think about a room, right? If you open your door, air can come in that door and it influences what's happening in the room. All right. So an open system is one that is essentially, we could essentially say non-conservative, right? This is the type of system that essentially allows outside influences okay? Closed systems are ones that basically do not allow outside influences, okay? So these are going to be what we call our conservative, okay? And then there's something called an isolated system, which again, in reality, there's really nothing that really is a truly isolated system. So I'm not going to really get into the weeds with that one. All right, so I'm probably going to use more the idea of conservative versus non-conservative. Okay, something else that I like my students to know is the difference between transfer of energy. This is what happens between the systems, all right? So again, something that's important here, there's a transfer, right? We're taking something from one place to another. It's, again, that idea of something's open to an outside influence, okay? Secondly, a transformation, okay? Transformation is a transform, right? We transform. Something's changing. This is changing within a system itself. Okay, so there's some preliminaries. Another preliminary thing that we need to talk about is gravitational potential energy. Okay, this is really, really critical. And this is a mistake that I made for years and years and years before I truly understand. Do I truly understand? Maybe I'm at 99%, and somebody that's at 99.8% is going to come up and understand better. Okay, help me out. So basically, if we have, typically, this is a very typical situation where we have a ball and an earth, right? So our ball has potential energy because of the fact that there's an earth there, right? This system, the ball or system, has potential energy, and it's due to the actual relative position of these two objects, all right? I'm going to leave it at that. What is work? Okay, and again, this is where I think I think about things differently. And again, is it for the good? Is it for the bad? I'll let you be the decider on that one. So typically, work is this idea that it's basically using energy. And again, there's terrible definitions out there for this, but I think of it as a transfer between two systems. So let's imagine we have a block, right? And we put this block on a table, and that block is basically stationary. So it has no energy. Well, along comes a hand. Okay, this is a hand and not a bunch of bananas, but this hand comes in contact with the blocks, and the hand is outside of our system, right? It is not, it's not part of the system, and it pushes on it, right? Exerts a force, and as a result, the box begins to move. Well, now the box has kinetic energy, and it has that kinetic energy because the transfer, right? The transfer of energy from where? Between the two systems. Between the two systems, one of those systems being the hand and the other one being the box, right? So the hand transfers some energy into the box, right? Okay, another thing that I want to mention that you're going to see me use here, and this is different. A lot of people use the letter W for work. I actually prefer to really drive home the idea that work is energy. Okay, so I'm going to use E sub W. In fact, you'll see me use E for all types of energy, when subscripts denoting the specific type of energy. So you'll see me use EW. You will also perhaps see me use ENC for non-conservative, okay? Again, this is that work. It's work done by some other system. All right, one last thing before we get to the situation. I rely heavily, a lot of students want to go straight to words, and I know I hear this all the time, well, what equation do I need? Well, we don't really know the equation until you truly understand the situation. Okay, I rely heavily on drawing pictures and understanding the situation through graphs. Students often say, well, I got the right answer, meaning they got the right number at the end, but like they didn't use the right process. Okay, so physics is a very process-oriented endeavor. All right, here's our situation. So we have a ball, and the ball is near the surface of the Earth, and the assumptions that we're going to make here, these are pretty standard kind of assumptions, that the gravitational field is a constant, okay? And again, that's due to the fact that we're basically lifting this very, very small relative to the actual radius of the Earth. We, of course, ignore air resistance. That's just what we do. Otherwise, things get difficult. And again, one thing I want to say here, when I'm talking about energy in this situation, you'll probably hear me say energy. I'm really talking about mechanical energy. I'm ignoring things like, you know, thermal energy, sound energy, all those other non-mechanical types of energies that simply don't come into, you know, into play. Well, they do, but, you know, they don't. Okay. So our ball starts at rest, and because it's at rest, the type of energy it has is kinetic energy, or the type of energy it could have is kinetic. Since its velocity is 0, we have 0 kinetic energy. All right, our free body diagram is essentially the force of gravity. That's it. There's a force on the ball, and it's by the Earth. The Earth is what causes that force. It's the attraction of the Earth for that ball. That is what we call a free fall situation, right? So the acceleration will, in fact, be equal to g. Now, I have my students fill out what's called a work energy table. And in this work energy table, we basically define our system, in this case, the ball. And again, I want to note here, the Earth is not part of the system I'm defining. I'm not saying the Earth doesn't exist. Oh, it certainly does. But this system is just the ball. All right, in this column, we list down the forces that act on our object. In this case, there's only one. In this column, we decide, is there work being done? Is it positive work? Is it negative work? Or is there 0 work being done? And then in this column, we're deciding if it's non-conservative or conservative work. All right, so essentially, here's kind of the way we look at this. Since our ball is the system, okay, ball, that's it, ball. And this force here is caused by the Earth. That Earth is external from the system, right? It is external from the system. It is an outside influence. It's no different than our hand pushing that block from earlier. That is it's doing positive work because it's putting energy into the ball system, right? It's going to make it get faster. And so because it's external, that is a non-conservative force in this defined system, all right? Now, let's get down to kind of equations-wise. Here's what's going on. Basically, in our equations, the initial energy, because there is no kinetic energy, is 0, right? So this part goes away. The non-conservative work that's happening is done by the force of gravity moving at the distance d downwards. The angle between those two vectors is actually 0, so that's going to give us a cosine equaling to 1. And the kinetic energy is also 0, right? So that goes away. I don't know why I have it there twice. I canceled it out here in this part. And then, so basically what this is saying is that the work that we do, right? The work, I should say, the work that the Earth does, right? The work that the Earth does on the ball is going to be equal to that final kinetic energy. So in my energy accounting system here, I notice that my system, right? I put a box around my system. The box has no energy in it, right? There is no energy in that system to start. And then at the end, my system, all right, has the energy. That energy, where did it come from? Well, the energy was transferred into the system, right? Notice that it's transferred, not transformed, it's transferred. So that energy that was once here has now ended up into there, okay? So that basically if we did 10 joules of energy or 10 joules of work, our system at the end has 10 joules of energy. All right, let's look at things a little differently. So notice here, same exact situation. We're gonna have a ball, starts at rest, it goes down and it obtains some velocity here, some final velocity. And basically, once again, same free body diagram, it's a free fall situation. And let's take a look over here. Notice how I'm defining my system. I'm defining it differently here, right? This is the ball Earth system now. So I am including the Earth in the system. So the energy accounting looks a little different now. So my energy accounting has to take into account that there could be kinetic energy and there could be potential, right? Once again, 1/2 mv squared, our velocity is 0. So the energy in the end is equal to 0 for kinetic. Our potential energy is 1/2 mgh, which all of those values are non-zero, so that is not going to be equal to 0. So it's basically a non-zero value for potential energy. When I get to the ground, the kinetic energy is going to be, because it will have a non-zero velocity, right? That is not going to be equal to 0, but because it's now on the ground, or I should say just as it's getting to the ground, our height is essentially 0, and that means our potential energy is now 0. All right, so again, let's kind of take a look at how this plays out with equations. Essentially, in this case, there is no non-conservative work, right? So non-conservative work goes away in this case. What are we left with? Well, we're left with our total energy at the start has to equal the total energy at the end. And again, this is a transformation, right? This is a transformation. The energy is transforming within the system itself, right? This is the stuff here that's in the system. So let's take a look at this. Our kinetic energy at the beginning is 0. Our potential energy at the end is equal to 0. And so essentially our potential energy at the beginning has to equal the kinetic energy at the end. So taking a look at our energy accounting here, basically my system now includes, notice, 2 types of energy, right? This is the 2 types of energy that I'm dealing with, potential and kinetic. And essentially notice how the energy is staying within the system, right? It's staying within the system. It's just transforming, right? It's kind of sloshing back and forth or whatever between these 2 types of energy. Again, these 2 types of energy being within the system. Now, we could go further with this. I'm not going to do that in this video. I think this has already gotten long enough. But I hope this does lead to a different understanding. And I welcome any comments, suggestions. I'm not too big to understand that I probably make mistakes and that there might be different ways of looking at this. So I encourage discussion and good fishing, everybody.